So we're going to look at the general term of a sequence. It's still part of 8.1, just two tiny items. So the general term of a sequence is denoted by AN. And you can say, what if it's a sequence in B? Okay, it will be denoted by BN. What if it's a sequence in T? Okay, fine, it's going to be TN. It doesn't matter. The letter is not important. But that's the general notation for the general term of the sequence. Okay. In other words, in which we plug in 1 to find the first term, we plug in 2 to find the second. And I'll illustrate this with it in a minute. So let's look at problem 4. On page 752, we are given the general term of the sequence as being 1/3 raised to power n. And they're asking us to determine or show or find the first 4 terms of the sequence. So when n is 1, I would get 1/3. The second term of the sequence is when n gets replaced by 2. So then I would get 1/3 squared, and the simplified form will be 1/9. And then A3, which will be 1/3 raised to the 3rd power. Obviously, it's 1/27. And the last one is A4, 1/3 raised to the 4th power, which is 1/81. So if you want to present this sequence, you will say 1/3 is the first term, 1/9 is the second term, 1/27, 1/81, dot, 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 comma, 1, I shouldn't write it there, comma, 1/3 raised to the nth power. That's your general term. So maybe I should write it again because it's broken. It's not, doesn't look right. So it's 1/3, comma 1/9, comma 1/27, comma 1/81, comma 3 dots, 1/3 to the nth power. And if you want, you can continue. Say that's an infinite sequence, not just a finite. It doesn't stop at n. It goes on forever. Okay. Very good. So let's look at another one. Let's say 11 on the same page, 752. A sub n, the general term, is -1 raised to power n plus 1, n plus first, and 2 to the n minus 1. They want us to determine the first 4 terms. And we will see, you'll see problems like these here. So here it is. That's the same one. I just copied it from. So it's -1 to n plus 1, and I changed 2 into 3. So on this paper is 3 to the n minus 1, and here is 2 to the n minus 1. So we're asked to find the first 4 terms. So A1 will be -1 to the 2nd power over 2 minus 1. The numerator will be 1. The denominator will be 1. So the first term of the sequence is 1. So A2 will be -1 raised to the 3rd power over 2 squared minus 1. So the numerator is -1. The denominator is 4 minus 1. So this is -1/3. As you see, the terms of this sequence are alternating. The first one was positive. The next one is negative. What do you think the third one would be? Positive. Yes. So -1 to the 4th power over 2 to the 3rd minus 1. -1 to the 4th power is 1. This is 8 minus 1, which is 7. So it's 1/7. I didn't have to write it again. And we can write the 4th term as -1 to the 5th power, 2 to the 4th minus 1. The top is -1, and 2 to the 4th is 16 minus 1 is 15. So this is -1/15. So these are the first 4 terms of the sequence. Given the general term. Now, there is a second option. And the second option is when we are given a relationship called recursive formula. So we are not given, like in the previous examples, the general term in terms of n and numbers. We will be given the general term in terms of previous term or terms. So here's an example. Let's say 17. Same page, 752, in which we are given a1, which is 4, which is the first term of the sequence, and we are given an, the general term, but is not a clean cut. Greater than or equal to 2. Meaning, as you see, the general term depends on the previous term of the sequence. So obviously, if n is 7, if this is a sub 7, what will this be? A sub what? Yes. So this will be the previous term, which is a sub 6. So we are not really given the general term a sub n clean, if you want. We're given a relationship that will eventually give us any term of the sequence. The same question here, we are asked to find a1. Okay, well, they have to give us the starting point, and they did. a1 is 4. But in order to find a2, can anyone see the pattern and tell us what to write? You're going to say 2 multiplied by 4 and plus 3, because 4 is the previous term. 2 times 4 is 8, plus 3 is 11. Now what will be a3, which is the next term? Exactly. Very good, Dan. Thank you. So plus 3. So this is 22 plus 3 will be 25. And we can continue forever, but they are only asking us to present the first 4 terms of the sequence by simply looking and understanding the pattern. So a4 is 2 times 25 and plus 3. The same, but just that this is the previous term. So 53. So what will be this sequence? 4, 11, 25, 53, ... I don't have a clean general term. And this is the end of everything I needed to present. We needed to look at this semester. So now, please tell me what you would like to continue. Yes, let's go to number 1. In number 1, we have g of x equals negative 7 raised to x plus 1 plus 49. I copied this from my math lab. So I'm hoping you're going to be done by Monday. So we can put this behind us. Okay, so I'm asked transformations, I'm asked find domain, find range, find asymptotes, whatever, graph, present the transformations in order of operations, the whole spiel. Okay, so first of all, I identified that the base for this function is 7 raised to the x power. Excellent. That's the exponential function that we know. We remember how to graph. It's an increasing function because the base is greater than 1, and it will cross. So this is 7 to the x, and it must cross at 0, 1. So this is very clear. Now, the first transformation in order of operations. Excellent. Thank you, Rachel. 7x plus 1, which will do what to the graph? Right. Where will I move the reference point? Very good. What is this point now? Negative 1, 1. Very good. Awesome. So this is the graph of 7 raised to x plus 1. Very good. Now transformation number 2 in order of operations. What would be the next step in order of operations? That would be? Very good. Okay. Now see, nothing changes in here. X does not change. But what does it change? Y. And what do I have to do? Exactly. Awesome. Now I need this point. Tell me where this point is going and I will plot it. Negative 1, negative 1, negative 1. Perfect. So this is the graph of negative 7 raised to x plus 1. Final step, negative 7 raised to x plus 1 plus 49. Up 49. However, these three functions have a horizontal asymptote, which is y equals 0. I have to shift the horizontal asymptote first. Where will I shift it? Up 49. So my apologies, I didn't plan ahead. So I don't have enough room, so please bear with me and say that that is 49. We all know it's not, because the scale would be incorrect. Okay, so now please tell me, where does this move, and I will graph the final graph. Negative 1, comma, excellent. Negative 1, comma 48, and here's the graph. So this is the final graph. I'll say final, which is negative 7 to x plus 1 plus 49, and this is f of x. Great job. We need domain, and we need range. Yes, it's an exponential function, so we are never going to have problems with the exponential function. What about the range? Negative infinity to 49, excellent, with a parenthesis because that's the horizontal asymptote. Well done. I also want to find the x and y intercepts. I don't know if this is the correct y-intercept. I wasn't asked to find that using transformations, but now I can algebraically. I'm not sure that this is the exact x-intercept either. So what do I do? Say it again?
Put it in the calculator.
No, no, no. Much easier than that. How do I find the x-intercept? Very good. So then I have negative 7 raised to x plus 1 plus 49 equals 0. Excellent. How do I solve this equation for x? So I said y equal to 0 in order to find the x-intercept. Good. So then how do I continue? Of course. I'm moving 49. What do I do next? I can't, because it has a power. But I can divide both sides by, and I have to. Negative 1, or multiply by negative 1. 7 raised to x plus 1 equals 49. Now I'm asking myself, what type of equation is it? And I notice something very important.
You can set 7 to 7 squared.
Exactly. 7 raised to x plus 1 equals 7 squared. So what must happen?
X plus 1 plus 2.
Which means that x must equal,
1.
indeed. 1 comma 0 is the x-intercept. So I'm way out there. So it should have been here. I don't care. I wasn't calculating anything. I was just applying transformations to graph the function. But the graph should have crossed through this point, like this. You don't have to erase anything. Okay, how do I find the y-intercept? Excellent. So f of 0 will be negative 7 to the first power plus 49. So this will be 42. I don't know if this is 42, but it should have been 0 comma 42, as this should have been 1 comma 0.
So for a problem that has a bigger number like this, you're okay with us showing?
Yeah, I'm going to make sure that it's not. Yeah. Yep, that's it. Any questions? So we completed the first problem. I think we should finish the last few because we just finished that material, so you can work on more problems. So let's do the last 2 pages first, if you want to, or if you have something else in mind, I'll do whatever you want me to do. Please choose.
Can we just start at 18 and go there?
Yeah,
Well,
I think
sure.
those gaps Jordan stuff out of the way.
Okay, very good. Very good. So can anyone give us the augmented matrix for Gauss-Jordan?
1.
But you have to tell me, do you give me
Row versus row is 1.
Okay.
Except for 0 and none.
okay, I wasn't sure whether you were giving me by columns or by rows.
Second column.
Oh, go ahead.
1
Perfect.
And the third is 1, -1, 1, 2.
Excellent. Remember the sequence of steps. We cannot ever deviate from the sequence of steps. We have to obtain the one that will enable us to get the zeros. We have to determine the one that will enable us to get the zeros. Finally, we have to get the one. With this one, I will determine the zeros. Clear? Okay, perfect. So then first step, please.
Times -1.
So this is done. Very good. So we are going to use row 1 and add it to, notice that when you read this in the book, they are going to, what they present in the book is every step, which is fine, but it will continue like on 3 pages because they don't do 2 steps in one. I like to do 2 steps in one. If I need to multiply row 1, let's do it together because then we're gonna get confused. We have to copy that row twice instead of just once. So I recommend this, but I accept any method. And I remember I also accept the Gaussian elimination. If you say, I don't like this, I want to use Gaussian elimination, which I think it's more difficult, but some people, some students.
I have a question about that, because I think that
Sure,
the homework makes us do that.
do whatever you want. They cannot do, they
Well,
cannot,
it won't let you fully solve it, like it doesn't have the full answer, but I'll ask that after this.
so it's only asking you to multiply, and you can skip those problems if you want to.
It still breaks down.
No, it's like on my homework for score, like for points. Like if I go back to the other one, I have to pick, I obviously know it's C or D because I know that it needs to be 1, 0, 0. But it stops there.
So, so here, for Gaussian elimination, you would have the ones and you have the zeros at the top. Let me copy this problem. Do you allow me to copy
Oh,
this
that's fine,
problem?
yeah.
Okay. First, let's finish because we started this one, and then I want to
Yes.
copy the problem to show what happens there. Okay, perfect. So what do I multiply the first row by to add it here to get the 0? We all agree. What do I multiply this row by to add it here to get the 0 here? Perfect. So which row do I have to copy because that will not change for sure? Right, because I'm using it. If I'm using it, it cannot change. Good. So let's do this together. 1 times -1 plus 1. Excellent. 1 times -1 minus 1. 1 times -1 minus 1. 0 times -1 minus 4. Perfect. 1 times -1 plus 1. 1 times -1 minus 1. 1 times -1 plus 1. 0 times -1 plus 2. 2. We accomplished this. Where am I now? And I cannot deviate from that.
You have to get that center -2 to be a 1.
Good. How do I make this into a 1? Row 2 divided by -2. Awesome. So I copy everything now except row 2. So I have 1, 1, 1, and 0. 0, -2, 0, and 2. Of course, this is carved in stone now. So -2 divided by -2. -2 divided by -2. -4 divided by -2. Excellent. So now I'm happy. I will use which row? Oh, of course, row 2 and add to row 1. Row 2 and add to row 3. Oops. Row 3. This is the key. So now I have to get rid of this and of this. So I have to use that middle row. What do I multiply the middle row to get a 0 here? Excellent. What do we multiply the middle row to get a 0 here? Excellent. Good. Which row do I have to copy?
Second.
Yes. Very good. Let's do this together. 1 times negative 1 plus 1. 1 times negative 1 plus 1. 2 times negative 1 plus 0. 1 times 2 minus 2. 1 times 2 plus 0. 2 times 2 plus 2. Where is my focus next?
We divide
Row 3.
by 2.
I have to. Row 3 divided by 2. Perfect. So 1, 0, 0, negative 2, 0, 1, 1, 2, 0, 0. Very good.
Okay,
This is all done. Yes.
yeah, so, I mean, couldn't we theoretically, at this point, instead of having to go through another one of these guys, can we just, because we have X and we have Z, couldn't we just like plug those in and find Y instead of having to do another, like, thing with this, because we, you know what I mean?
Yes.
Is that-
So we can stop here and do that. So I do have that z equals 3.
Yeah, and then
But
we
then
got,
I have to write a new equation. So from here I know that z equals 3.
and you know your X.
But from here, yes, it happened that in this case I know x. So I know that x equals negative 2. So now I have to write this equation, which is y plus z equals 2, in which I replace z by 3. So y plus 3 equals 2. So then y equals negative 1. That's fine. However, if you have other numbers here, then you have more calculations. That's fine. So here you have 1, 2, 3, 4, whatever, 3 steps. But look at what happens here. I only have to multiply row 3 by negative 1 to add it to row 2, and I'm done. Yeah, I'm fine. I accept both. So here we have 0, 0, 1, 3. 1, 0, 0, negative 2, 0, 1. So we have
What's the magnitude of the R3 times negative 1?
this times negative 1 is negative 1 plus this is 0. And 3 times negative 1 is negative 3 plus 2 is negative 1. Exactly what we got here. But writing it and replacing it and substituting versus just one more row. It's up to you. I'm fine. And then we go back and check. Good. Next question. You still want me to, Mallory, you still want me to copy
So,
that?
is that what they're trying to get me to do?
Yes.
The other one is to stop there and solve it that way? Okay.
It's called back substitution.
Okay.
So it's Gaussian elimination with back substitution.
That makes sense. I can do that one. I just wasn't sure.
I accepted. I'm fine with it. I just think that stopping in the middle and then changing the whole thing into something else and going and substituting, but it may work for some, and I will definitely accept it. Good. Next question.
Are we doing number 18?
Oh, this was 18.
So we're gonna do
Yeah.
19, 19, 20.
Oh, 19. Yes, 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 of course. So for 19, we have the general term is given nice and clean. We did the other one with 2, so let's also do this one. Why not? A1. Can anyone give us A1? I don't want to forget, I always encourage my students to complete the student opinion forms, and I will add 5% to each and every one of you who will show me the last screen where it says I completed the survey, nothing else.
I already did it.
That's fine, you can still go in.
Oh,
Click on student opinion forms and open it and just take a screenshot or with your phone and show it to me next time. Yeah. Where it says it's completed. Yeah. I give an incentive because in the past we had them on paper and most students would give me feedback. Now, I can't force anyone to go in and complete a survey. So if you ask me, I'm sure you're probably in the same boat. Oh, another survey. So I understand that. However, I have to encourage my students and kindly ask them to take the time and complete the survey for many reasons. And here's one. This never happened to me, but it could be, they could think that I had a reason why I didn't encourage you to submit this. Or maybe I'm not coming to class. Maybe I'm not presenting material. Who knows? They need to know. Okay? So I don't want anyone to think that I have a reason why not to encourage you to. I'm not saying that this is how they think. I'm just saying it could look that way. And we do have people that I know, no one fills out the survey. And that's, I think, not okay. Ready? So -1 to the second power, 3 minus 1. So this is 1/2. A2 is -1 to the third power over 3 squared minus 1. The top is -1. 9 minus 1 is 8. Another alternating sequence. A3, -1 to the fourth over 3 to the third minus 1, which is 1 over 27 minus 1, 26. And let's stop and see if you have any questions before we look at the last term that we need to determine. I mean, we can go on forever. But we are only asked to practice with first 4 terms. So A4 will be -1 to the fifth power over 3 to the fourth minus 1. But that's 81 minus 1, which is 80. And the top is -1. And as I said, we can go on forever, but there is no need. We are only asked to work on or determine the first 4 terms. Okay, so this was 19. Now we are given a recursive formula. A1 is given. A sub n equals 3 times a n minus 1 plus 3 for n greater than or equal to 2. Okay, so A1 is already given to us. So now we have to determine A2, which will be 3 multiplied by 4 and plus, good. So this is 12 plus 3, which is 15. A3, what will A3 be? Do we understand this, everyone? Rachel, are you okay?
Yeah, I just because in the last one we minus, so it was n minus 1 for n.
But you mean this one?
Yeah.
But this is not given recursively. This is clean cut. So a sub n is this, when n is 1. But here, this one is not. This one is, it depends on the previous term.
Okay, so we don't like 4 minus 1 since 4 was the previous term.
No, this is the name of the previous term. So if this is 7, this will be a sub 6. The previous term will be a sub 6. In order for me to get to the 7th term, I have to find the 6th term. Once I find the 6th term, it will be 3 times the 6th term plus 3. So that's why a sub 2 is 3 times the first term plus 3. And that's how I get 15. Now a sub 3 will be 3 times the previous term and plus 3, which will be 43. 33. No. So it's 45, I'm sorry. Sorry. 45 plus 3, which is 48. And then the last one that I need to determine, I can go on forever, will be 3 times 48 and plus 3. 144 plus 3, 147. Any questions on recursive formulas? So remember, there is a pattern or relationship with the previous term or previous terms. It's possible. But if it's connected to two previous terms, then we have to be initially given A1 and A2. Good. So then the next one, we have n plus 1 factorial over n factorial. We're asked to simplify this. Of course, we cannot put this in the graphing calculator. So how do we simplify it? Is we start with the biggest of the two, the largest of the two. Which one is the largest? Is it n plus 1 factorial or n factorial? Right. So keeping in mind that the denominator is n factorial, how will I rewrite this?
N plus 1 times n factorial.
Exactly. You don't have to list them because I can simplify. And the answer is just n plus 1. Any questions? Is this okay?
Yeah, no, when I did it, I just crossed out the wrong thing.
Okay. But is it clear now?
Yeah.
Good. The next problem, we have expressed the sum using summation notation. We're not asked to calculate it. We're only asked to express it. So 1 plus 3 plus 5 plus 3 dots plus 2n minus 1 equals the sum. So how do I write this? So that it includes everything that I see. Let's use J. J equals, okay. What is the last one?
2. So n.
It would be n, right? Of what? So it's 2j minus 1. Well, let's see. When j is 1, I have 2 minus 1. Do I get the first term? When j is 2, 6 minus, 2 times 2 is 4 minus 1, 3. Do I get 3? When j is 3, 2 times 3 is 6 minus 1, is it 5? And when I get to finally n, do I get 2n minus 1? That's it. Okay, and that's evaluate 40 factorial over 450. It's yes? Please. You want to use k. It doesn't matter. It's just the index. We normally use for indices I, j, and k. Why? Because they are somewhere in the middle of the alphabet, and we say I, k, j from 1 to the last one. We normally don't use A, B, and C or the last letters of the alphabet. We use the middle ones.
You can use either I, J, or J.
Yes, anything you want. Even if you use A, it's up to you. It's not going to make any difference. It's 2a minus 1. But normally we don't use the first, but this is perfect. It's going to give you the same thing. But normally we use I, j, and k. Okay, so for 40 factorial divided by 450, careful with that because when you put in the graphing calculator, 40, go to math, go to probabilities, choose 4, and divide by 450. So be very careful and read because this is such a huge number, it doesn't fit anywhere. It has 45 digits after 1. Okay, so it's 1.8 times 10 to the 45th power.
That's how you write the answer.
Yes?
So that's 1.8, estimated 1.8.
Yep. It's so big that I can't even tell you what it is. Okay, so that was the last, there were the last sections from 6 and 8. Okay, let's go back to anything that you would like to go back to. Number 3 it is. Number 3. Perfect. You will be given the formulas. So the the compound interest. So remember, you don't have to memorize them. I'll give them to you. So A equals P, 1 plus R over N raised to N times T. And the other one is P e to N T, KT.
RT?
Yeah, because that's spelled earth. The other shape.
You mean the first one?
No, the second
So-
one.
The second-
Yeah, K or R, the same thing. They're all the same.
Okay.
But since we used R in the first one, let's use R. I completely agree. RT times T. Good. So we are given P, which is 11,000, the principal. We are given T, which is 5 years. We are given compounded monthly, so N equals 12. And R, for this problem, for the first one, is 12%, 0.12. For the continuously, for this one, R equals 0.1191. So that's in a way why I was thinking of not using the same letter. It is the same letter. It is the same rate, of course. But for the first situation is 0.12, and for the second situation is 0.1191. Ready? So the first one. The first one we have A equals 11,000. 1 plus 0.12 divided by 12 raised to 12 times T, 12 times 5. And the second situation is 11,000 still, e to 0.1191 multiplied by 5 years. We will not create functions for this, for these, because we only plug in one number. Ready? So we have 11,000. And in parentheses, 1 plus 0.12 divided by 12. I could have written just 0.1. No, 1. Oh, 1. Okay, never mind. So caret, don't forget in parentheses, we have 12 times 5. Yes, you can write 60. You don't have to write 12 times 5. And in the meantime, I'm writing something else. Okay, so now we press enter. And then the other one will be 11,000 and E raised to in parentheses. And we have 0.1191 times 5, close the parenthesis, and press enter. So these are the numbers. The first one is 19,983. We have to present 2 digits, decimal digits. So 19,983.66. And the other one, 19,953.31. And now we have to make a decision. I know it's not a big deal, but in the long run, if the 5 years become 50 years, the difference may be substantial. So what would you say at this point? What would you choose? Yes, monthly at 12% is better than continuously at 11.91%. Very good. Next question, please.
So that's it.
That's
Is
it.
that like for number 2? Do we do that too?
Yes, we'll do 2. Yes, one more step. Yes, the formulas actually are given up here. Yes, Sissy, go ahead.
So number 3 is 2 columns and 1.
No, you have to determine 2 numbers and you have to make a decision. You're using 2 different formulas, but it's only one problem. You are asked to determine 2 quantities and compare them. So problem 3 is just one problem. Is that okay?
Yeah.
Why would you say that there's two problems? Or
Because you did two different formulas.
because that's what I'm
Different
asked.
results.
Because that's what I'm asked. I'm asked 12% compounded monthly, which is this formula. And then 11.91% compounded continuously, which is this formula. I have to determine both.
Oh, okay.
So it's one problem. I'm determining two quantities, and then I'm comparing them and making a decision. Is that better?
Yeah, kind of.
Okay. So let's look at 4. In 4, we are given the same thing, but this time the investment or the principal is 10,000. We are looking at n equals 4%. 3 years. T equals 3 years. Interest rate R 0.04. Remember, we cannot use percent. And we are told n equals 2, n equals 4 quarterly, n equals 12, and the last one is continuously. For these, I will create the function. I will put the function in y equals. That's me. You don't have to if you don't want to. So it's 10,000, and in parentheses 1 plus 0.04 divided by x raised to 3x. X being 2, and then 4, and then 12. It's only because it's easier for me to put the function in, and instead of messing with it and creating or redoing the same calculations 3 times. So we have 10,000, parentheses 1 plus 0.04 divided by x. We don't have n in the calculator. Caret. We do, but it means something else. In parentheses, I have 3 times x. Close the parenthesis. And now I go to second and table, and I put in these numbers quickly, and I get 2, and then 4, and then 12. And I get them right away. So now careful, because you have to go back and highlight them, because as you see, the digits do not appear. Maybe they appear in your calculator, but not in my software. So A of 2 is 11,262.61.62. A of 4, I think in the regular calculator it gives at least 2 digits. I think, maybe 268.25. And the third one, 11,272. A of 12, 11,272.72. And now the last one, I don't need to put in the calculator because it's just one calculation. So I'm just going to go to 10,000 e to power, what was it, 0.04 times 3, close the parenthesis, and enter. 11,274.97. So A continuously, 11,274.97. And that was problem 2.
Can we do this one?
Oh, yes, yes,
Because
yes.
I'm working through it, doing things I can do work to get me the answer, but I'm
Yes.
not hitting this.
It's the same one that we discussed.
Yeah,
Yes, yes, let me copy it.
I've been playing with it and it's just not. Like I got a fraction for one of the numbers on the right.
It's very possible. I did something. Is it question 1? Okay, question 4?
Whichever one I'm
I don't know
on.
what I don't
I'm
know
on
what
4.
I
It's okay. It's a separate. Oh, hold on. It should still be there. There we go. I was
Okay.
just trying to make it bigger so you could.
Okay, very good. So we have x plus y minus z equals -4. And we have 2x minus y plus z equals 1. And -x plus 5y minus 4z equals 1. Okay, and use Gaussian elimination, and then we will choose from here. Ready? Perfect. For Gaussian elimination, the idea is this. It doesn't really matter, but it's nice if we have 1, 1, 1. These are all zeros. Just these three are zeros. And then whatever, I'm going to put A and B and C and X, Y, Z. So that's all we really need. So to obtain the zeros at the bottom, so the 1, 1, 1, although even if these ones are not ones, but it's easier if they are, we can still, if they're not ones, we can still find the solution. So here's our example. Let's copy it. 1, 1, negative 1, negative 4, and 2, negative 1, 1, 1, and negative 1, 5, negative 4, and 1. So remember, I'm only interested in getting the zeros here. Ready? First of all, in order to get the two zeros, I will use.
Trying to change too many numbers.
So I need to use row 1 and multiply it by something and add it to row 2, and row 1 multiply by something and add it to row 3. I'm only focusing on these two.
-2.
Yes, for the first one is -2, and for the other one by 1. Good, excellent. Which row do I have to copy because I'm using it?
Row 1.
Yes. So this is the 1, 1, negative 1, negative 4. Together, please. 1 times -2 plus 2. Perfect. 1 times -2 minus 1. Excellent. -1 times -2. 2 plus 1. Excellent. -4 times -2. 8 plus 1. Excellent. 1 times 1 minus 1.
0.
Excellent. 1 times 1 plus 5.
5. Oh, 6, sorry.
Perfect. -1 times 1.
1.
-1 minus 4. Perfect.
Oh, row 1 is negative. Okay.
-4 times 1
-4.
plus 1.
-3.
Perfect. The only thing I need now is to make this into a 0, but I'm not ready yet. I have to make this into a 1. How do I make this into a 1 first? Both sides by? Excellent. Row 2 divided by -3. Well done. Perfect. So let's do just that. So I copy the first row unchanged. I copy 0, 1, -1, -3. And I copy 0, 6, -5, -3. One more time. -3 divided by -3 is 1. 3 divided by -3 is -1. 9 divided by -3 is -3. Okay, so this is done, this is done. The only concern I have this and nothing else. So it's only row 2 times -6 and add it to row 3.
Do we have to make the 1, that center 1 before we can do the 0?
Yes.
Because that's the
Yes.
normal way we do it?
Yes.
Okay.
Yes.
And that 1 isn't significant other than the fact that that has to be the step before the.
Because
Before that.
without this, it would be difficult to find. Yes.
Okay.
So here it is. 1, 1, -1, -4. 0, 1, -1, -3. 1 times -6 plus 6.
0, 0.
That's okay. -1 times -6 is 6. Minus 5 is 1. 18 minus 3, 15. I have what I need. All the diagonals have 1, and underneath I have
I have a
zeros.
quick question.
Sure.
When did that top right -1 become a -1? Wasn't it a?
I
Oh, I
copy.
copied it wrong. I copied the wrong number there. Nope, that's all.
I do that a lot.
I wrote the wrong.
So now here's what we do. That's the next step. We know that z equals 15. But now I have to write a new equation, which is y minus z equals -3. I have to replace z by 15. Y minus 15 equals negative 3, so y equals 12. Then I go back to the first equation. I write that as x plus y minus z equals negative 4, in which this is 12 and this is 15. So then x plus 12 minus 15 equals negative 4. This is negative 3. I add it to both sides. I get x equals negative 1. I think that this is way longer than one more step for row 3. If you say, no, I prefer this, I'm fine. Use it. Now, be careful. You still have to check, because here, like with this Gauss-Jordan, mistakes can occur any moment. I think, again, that this is longer, but maybe it's easier. And if you consider it easier, then use it. I'm fine. Good. Is this better? Mallory, is this okay?
Yeah, no, way better.
Perfect.
There's not gonna be an AC type on the test, right? Just
No, now Gaussian.
other-
But if you want to say, I prefer to stop here. I got the ones on the diagonal. I got the zeros. I want Gaussian elimination with back substitution. I will give full credit.
Okay.
If you consider that easier. So you understand that here there is an extra step for the 0 up here and 1 here. If this makes more sense to you, please use it. Very good. Next question.